the last session we discussed about vascular access. Since now we have a vascular access, we are ready to do an angiogram or angioplasty. So the next thing that is needed is a catheter. It can be a diagnostic catheter that is just for a diagnostic purpose for doing an angiogram, or a guiding catheter. A catheter with some specialized features, we will discuss about them, that is meant to carry hardware into the coronary vessels. So one important aspect before I continue this discussion is that often in your cath lab, we have this habit of taking in whatever is being handed to us by our supporting staff or technician. In 99-95% cases, it may be very useful, but in 5 to 10% cases, it can really result into some difficulties during the procedure. So it's very important that you are aware of the diagnostic catheters, what shapes that come in, what are their individual properties, so that you can plan your procedure beforehand and you save yourself time and energy. So about catheter size specification. This aspect, some measurements you should keep in your mind that is often used in intervention. We often use French. So one French is about 1/3 of a millimeter, that is 0.33 millimeters. And we use often in intervention practice 014, 032, 035. This term is often used. So what is this 013, 032, 035? So basically it's 0.003. So 013 is actually 0.013. So one French is equal to 0.33 millimeter, and it is equal to 0.013 inches. So when we say 032, that means it's 0.032 inches. So since I said one French is 1/3 of a millimeter, so 3 French is equal to 1 millimeter. So these unique measurements or units that are used in intervention, you should be really acquainted with, because it's going to help you in deciding hardwares that you're going to use. And one thing that you should remember, that whenever you do an access, you need a 6 French sheet. You tell your technician that give me a 6 French sheet or 7 French sheet. But at the same time, you say that I need a 6 French guide. So what is the difference? So you should keep in mind that the guide catheters or the diagnostic catheters are made in such a way that so for every catheter we have, so this is our outer diameter and this is our inner diameter. So the diagnostic or guiding catheters are made so that 6 French guide means that the outer diameter is 6 French. This is for a diagnostic or guide catheter. But for a sheath, when we say 6 French sheath, it means that it's referring to the inner diameter. So a 6 French sheath's outer diameter will be larger than the 6 French outer diameter of 6 French diagnostic or tight catheters. So access sheath internal diameter is equal to outer diameter of catheters. So this measurement you should remember, and it is always 1 French more. I mean, if you are saying that you are taking a 6 French sheath, that means the outer diameter of the sheath will be about 7 French. So what we mean here is that suppose you say 7 French sheath. So for a 7 French sheath, the outer diameter will be about 8 French. That is 8 into 0.33, that is about 2.7 0.6 millimeters. So this will be the diameter of outer diameter of the sheath. But the 7 French guide catheter will be about 2.3 millimeters. That is 7 into 0.33. So this is the difference. And the different catheters have a color coding that the 5 French has a light brown color coding. The 6 French has a green color. The 7 French is orange, and the 8 French has blue or violet color. So what's the importance is that when you are busy in a procedure and you ask for a respective guide catheter size of, so this color will help you. So this is you can see this is a green color, so this is 6 French. So this is how you recognize even by the color coding that what size that the catheter is being handed over to you. And the various manufacturers have the guide catheters whose inner lumen diameter may vary. So when they are saying that it's a 6 French or 7 French guide catheter, they are meaning that the outer diameter of the guide catheter is that, but the inner diameter will be often 1 French less. So for Medtronic's launcher, you can see that the 5 French, the inner diameter is 0.058 inches. And for the same, for the Cordis one is 0.56. So these variations are there. So whenever you choose a guide catheter, it is always good to opt for a guide catheter which has the largest internal diameter. So this is what is about sizes here. So just sum it up that for a guide catheter, the French size that is mentioned is the outer diameter, but for the sheath, the French size that is mentioned is the inner diameter. So what role a guide catheter has in a routine intervention? First of all, it's a vehicle for contrast injection. Through this, we inject contrast, the dye, to visualize various structures. It is used to measure pressures. What are the LV pressures, aortic pressures, pulmonary pressures, wedge pressures? All these we can measure directly, taking the catheter inside and connecting it to the pressure port. It helps for a support for device advancement. Whenever you do some intervention, we need a platform, we need a route, a tunnel through which we can take that thing directly to the respective target vessel. And definitely for a conduit for device and wire transport. So guide catheters can be used to insert various percutaneous closure devices, or they can be used to carry wires as a rail, or so that we can carry balloon catheters and stents into the vessel. So this is what our guide catheter or the diagnostic catheter role is. So when we say that to fulfill this role, what characteristics should be there? Usually the guide catheters or the diagnostic catheters have a preformed curve. This is to aid us to cannulate or intubate respective structures that we want to study. And definitely it has a very configuration with a atraumatic tip. So the tip, if you hold a guide catheter or diagnostic catheter, it will feel very robust and stiff. But if you feel the tip, it's very floppy. This is meant to prevent any damage through the tip to the respective vessel. So the unique property should be that it should be a atraumatic tip. Then there should be a torque control, so that when you rotate the guide catheter outside the body, it should result into a respective turn at the tip of the guide catheter, and it should be kink resistance, because you can have to go, or you go through various structures with tortuosity, and when you are pushing the guide catheter in, it should not kink, so that the shaft should be stiff enough to resist any kink. And it should be radio opaque so that you can visualize it easily. It gives support so that when you carry in a device, it doesn't buckle. And it should have a device compatibility. So the inner diameter or the inner lumen should be sufficient enough to accommodate the devices that you want to take in. So these should be the characteristic of guide catheters. So briefly, what's the difference between diagnostic and guide catheters? So the main features are the guide catheters have a larger inner lumen diameter and they are more robust or kink resistant. And the tips are lesser traumatic compared to the guide catheters, so diagnostic catheters. So these were the difference between the diagnostic and the guide catheters. Now coming to the parts of a catheter. So obviously a guide catheter is the standard length is about 100 centimeters. So most of the guide catheters or diagnostic catheters that come in 100 centimeter length. Some are there which come in 110 centimeter also, but the standard is that they come in 100 centimeter length, and it is sufficient for most purposes. So if you see the structures here, this is a snapshot of a JL diagnostic catheter. So obviously you have a tip. You can see that it is atraumatic, it's of different color, and the distal curve, that is the curve nearer to the tip, we call it a primary curve, and the curve proximal to the primary curve, we call it a secondary curve. This curve is meant or designed for definitive purposes. So it will be different for a catheter which is meant for intubation into a left coronary artery, and it will be different from what is meant for a right coronary artery, or maybe what you need for a SVG draft or internal mammary artery. And definitely there are differences in shapes for definitive purposes. We will discuss about that. And this is the shaft. So the main body that provides the support, and it is double layered in case of diagnostic catheters, and it is triple layered with a steel inner layer in between for reinforcement and stiffness. So the proximal part has a hub or the layer and a tension relief part that prevents it to get kinked at the access site. So these are the various parts of the catheters. And usually if you see that the catheters have numbers added to it, like for example GL 3.5, GL 4, what these numbers are. So these numbers are basically the length in centimeters or the distance in centimeter from the primary curve to the secondary curve. Then that means that when you say GL 3.5, that means you mean that you need a catheter where the primary curve and the secondary curve has a separation difference of is a 3.5 centimeter. When you say that you need a GL 4, that means you mean a difference which is 4 centimeter. So these numbers are the difference between the primary curve and the secondary curve, and this number is very important. I will discuss about that because the tip and the primary curve is meant to be near the respective ostia of the vessel. The secondary curve is meant to give support. So the larger curves will be good for a larger aorta because that is going to give you a counter support. So we'll discuss on that. So these were the parts of catheters. Now there are catheters which have end holes that just hole through which the contrast or the guide wire comes out. So the main lumen hole communicating to the main lumen in that the direction of the catheter. But there are side holes around. For example, pigtail has a central hole and a side hole. That's meant because pigtail has a purpose to measure pressures and to give contrast injections. Uh, so that's the whole purpose for that. So it's really makes sense to have multiple holes so that you have more contrast visualization. But when you are using diagnostic or guide catheters, there are some catheters that have a end hole, and even there's a practice that you put in a hole on the side to make it a side hole. So what is this side hole and end hole, and what purpose they serve? So side holes are useful where the pressure gets frequently damped, as in RC. So RC has such an angulation from as it arises from the right sinus valsalva that your guide catheter. So if I so this is an RCA. So there is a possibility that whenever you uh, so there is a possibility that whenever you intubate it, you are likely to touch the wall of the ostia. So what will it result is that there will be dampening of the pressures. So to prevent it, if you put a side hole here, then obviously it will reflect the pressure in the aorta. So you will not have that damping. It's useful for RC interventions, in situ intervention where you have a 100% occluded vessel and your guide is abutting to the 100% occluded vessel. So you don't have any pressure assessment. Then these side holes help to give you the pressure during the procedure. For example, sole surviving artery or left main interventions. So the advantage is that they prevent catheter dampening and allows additional blood flow out of the tip to perfuse the artery. So you are abutting the as in you are abutting the side hole, and you maybe have occluded the blood vessel, the ostia, but still some blood can trickle into the coronary artery. So that's the advantage that a side hole catheter has. But there are disadvantages. What are the disadvantages? It gives you a false sense of security because now aortic pressure and not the coronary pressure is being monitored. The disadvantage of a guide catheter or a diagnostic catheter abutting to a coronary ostial wall is that it makes it prone to dissection. I mean, you can put in a contrast injection. You see what is the practice. When we intubate a coronary vessel, we check for the pressure. We see whether the pressure is damped or not. So if the pressure is not damped, we conclude that the guide catheter or the diagnostic catheter is coaxial to the coronary ostia. So we can inject dye as we do with the same force. But if it is abutting to a vessel wall, coronary ostial wall, and if you inject it with the same force, there is always a possibility that you can dissect a flap out. So that's the reason that it gives a false sense of security, that the pressures are not down. So it can be really dangerous at times. And also, since a lot of dye may be coming out instead of going into the coronary vessel, so there will be suboptimal opacification. And since the tip has a hole here, so obviously the support that usual guide catheter has will be weakened. So there will be less support. So these are the advantages and disadvantages of the side hole. But for most purposes, now people don't use the side hole catheters because of these reasons. But definitely there are some catheters, for example, that the Tiger that is used for a diagnostic purpose always has a side hole, single side hole here. So this is a Tiger catheter that is used for transradial angiography. It has a side hole, single side hole, because it kind of has a habit to more aligned towards the ostial wall. So there is a dampening which is more frequent. So you should be very careful when you are using such catheters which have a side So after this introduction about the catheter size, what is the difference between diagnostic catheter and the guide catheter? What are the different parts of the catheters? Let's introduce you to some shapes that are used for intervention. For transradial intervention, diagnostic catheter is the most commonly used curve, and the advantage is that when you are doing a transradial intervention, you want minimal transpasses through the radial artery so that there is less chance of a spasm. And this tighter catheter, this shape you can see here, uh, it has a 90-degree primary curve, and then there is a secondary curve and a tertiary curve. This shape is so unique that you can intubate both the left coronary artery and the right coronary artery with a single catheter. It comes in 100 centimeter, 110 centimeter mostly, and so this is what we call a tiger catheter. And then you have a pit tail. I said it has 6 side holes. It can be angled pit tail, or so this is straight pit tail or the angled one. Then I introduce you to the Judkins left catheter, which has a primary curve and a secondary curve. It comes in JL 3.5 to JL 5, and then you have a Judkins right catheter for the right coronary artery intubation. It comes in shapes from 3.5 to 4 and 5 centimeter. So you can appreciate the difference between the, if you see here, this is the JR curve, which has a primary curve here and a broader secondary curve. In case of JL catheter, you have a 90-degree primary curve and almost 180-degree. This is the secondary curve here. This is JL. And then you have an internal mammary catheter, which is kind of a single, there is a broad secondary curve and an acute primary curve. And then you have these Amplards catheters. So this is the Amplards catheter. This is AL and this is AR. So the AL has a half circle curve, and with you can maybe say that a cobra type of distal tip, and it comes in sizes from AL7 0.75 to AL4. And then you have AR. The shape is similar to what AL has, but the half circle is smaller. So this is AR1 and AR2. Then you have a hockey stick catheter, which is like if you add another curve to an internal mammary catheter, it gives the shape of hockey stick appearance. And then you have this multi-purpose catheter. This multi-purpose catheter has a single curve here, and the advantage of multi-purpose is that it is, as the name states, can be used for multiple purposes. It can be usually used for pressure measurement as well as intubation of various coronaries, because it can be manipulated to different shapes in the aorta. Then you have, this is the internal mammary, another example of an internal mammary guide catheter here, and you can see the difference in the color coding. This is the tip, and this part gives the support to the shaft, which you can call, and the curves. So the tip is atraumatic for preventing any coronary artery dissections, and this curve helps to intubate various vessels. So this is internal mammary artery right catheter. Coming to Judkins catheter, so Judkins left and right, it is a 90-degree, almost 90 to 110-degree curve at the primary angle, and a 180-degree secondary curve. And as I said, that this distance makes the size. So the numbers refer to this distance between the primary and secondary curve. And for the JR catheter, is the primary curve and the secondary curve here. So this gives you the respective numbers that you have. So this was JL and JR catheters. Now coming to Amplards shape. So the Amplards has a secondary, it is meant this way that the secondary curve rests against the non-coronary aortic cusp. So this is the shape of the Amplatz catheter. It is made in such a way that that the secondary curve rests on the non-coronary uh, cusp of the aortic root, and it gives this shape gives it a good passive support. We'll discuss what is a passive support and active support. And the unique advantage of AL catheters is that they can be used to, particularly AL1, can be used to intubate multiple anatomies, whether corresponding to the right coronary or the left coronary artery. But there is one important aspect here about the handling this AL catheter is something which is really demands some expertise and some care. Because if you see here that if you pull this thing out, if you just pull this catheter out, what will happen is that if you are pulling it out, what will this curve do is that it will push the catheter tip because into the coronary artery. So there is a chance that you can injure the coronary ostia. So the trick is, what you do is that instead of pulling, what you do is that you push. Initial action when you are withdrawing this catheter is to push the catheter. The thing is that when you push it, the curve will prolapse out. So if you push down the catheter, the curve will prolapse out, and then you rotate it in either direction so that it becomes unaligned to the coronary ostia. So this is the trick that you use to withdraw this Amplatz catheter. So what you do is that you first advance slightly to prolapse the tip of the ostia, that you push down, the ostia tip will be prolapsed out, and then you rotate it. And this is how you can withdraw it. So even when withdrawing hardware, the tip of the Amplatz guide would have a tendency to be sucked in. To avoid this, what you can do is that pull the balloon out while simultaneously pushing the guide into prolapse the guide out. So the thing is that when you are pulling something out from the guide catheter, what you will do is that at the same time you will keep a force, a forward push into the guide catheter, so that the tip is not sucked into the coronary ostia. So, this is the tip that you should really practice when you are handling the Amplatz shaped catheter.